So the last concept, entropy, is a very more conceptual concept. You do more calculations of this if you take AP chemistry. But in AP Physics 2, you just need to know generally that entropy is the amount of disorder in the system, qualitatively. In a closed system, entropy can never decrease. And maximum entropy is when we're in thermal equilibrium. And let me talk about disorder. This idea of disorder is a little bit confusing to some people. But the idea is, suppose you have gases here. And the molecules in the gas could be in anywhere located, right? Like here you have gas molecules just located wherever throughout this container. Now this one is more chaotic. This has more disorder. Then let's say I were to take all the gas molecules and just pull them up into like one corner here like this. And so what ends up happening in a situation like this is this one has less disorder. There's more disorder here, because it's more like scattered. It's a messier mix of particles. More disorder, that means higher entropy. This is more organized or less disorder, so it has a lower entropy. So in general, things where there's more, it's kind of more spread out, more random, like where it's looking more chaos, more disorder, that has higher entropy. Now, why does that relate to temperature? This is the part that, like, it confused me a lot when I was young, when I was learning chemistry, and I was like, well, I don't understand the disorder, and how does that relate to the temperature side of things in thermal equilibrium? So imagine we have the same container now, but now we have some particles that are cold on one side of the area, and then I have another set of particles that are warm. So they're moving faster, basically. They have more thermal equilibrium. So you might think as a whole, this is more disorganized. There's like disorder here. But these are moving faster, so these are warmer. Like these air molecules are warmer. And these molecules here are cooler. Okay? This has more organization, less disorder than the case where the molecules intermix, collide, and then I know like some will be faster, some will be slower, but then all the molecules are at the same temperature on average. So it's like now we're at an equal temperature. So same temperature. And the whole idea in terms of the entropy is that this idea has more disorder. Because before you had the cooler gas and the warmer gas and they were kind of segregated, right? And then now that we've intermixed them and they're colliding and interacting and transferring kinetic energy, then the temperature evens out between all the molecules on average, right? And so then they're all about the same temperature. So again, this is a higher entropy because it has more disorder. So the maximum disorder occurs when we're in thermal equilibrium. That's what this statement here, maximum entropy is when we are in thermal equilibrium. So we have two objects at different temperatures are placed in contact inside an insulated container. Over time, they reach the same temperature. Explain how the entropy of the system changes during this process and why. Well, as it has the least disorder when they're different temperatures, and then as they're intermixing, it increases. So it is increasing over time until it reaches a maximum at thermal equilibrium. So when we're at the same temperature now, then we have achieved the maximum entropy. Okay? And in general, for a closed system, entropy doesn't decrease. Entropy can decrease locally. That is to say, I can separate these things by having cooler air and warmer air. So like, for example, that's how an air conditioner works. I can say like, well, outside is hot, inside here is cooler, right? And I'm enforcing that separation of temperature in order to keep the, so like I have less, in the system overall, we're maintaining less entropy because we're keeping the cold air separated like a refrigerator works that way. However, if you consider the system as a whole, like the entire Earth or like everything around it, then overall the entropy is increasing, even if locally, like inside the refrigerator, it has lower entropy because we've kept all the cold air just inside the refrigerator and kept it more organized and less disorder. Overall, if you consider the whole universe, the entropy is still increasing over time. Okay. So let's take another example. And the only kind of questions you're going to get are pretty qualitative when it comes to entropy. So in a closed, isolated system, a gas is released from one side of a container into an empty side until it fills the whole container evenly. Why does this increase the entropy of the system, and why can't the gas spontaneously return to just one side? Okay, so it increases because it increases the disorder. Increases disorder by having the gas all over the room. The container. I said not room, but container. Why can't it just go to one side? Well, basically, second law of thermodynamics says entropy is always increasing. So this is what if in the second law, that's the second law of thermodynamics. Okay, we don't need to say much more than that, but the entropy is always increasing in a system like that. Okay, block A and block B are both made of the same material and have the same mass. In scenario 1, one's at 80 degrees, one's at 20 degrees. In scenario 2, both block A and B are 50 degrees Celsius after being in contact for a long time in an insulated container. Which scenario has greater entropy and why? Here, because at thermal equilibrium, so it's greater in scenario 2. Because it is in thermal equilibrium, and that's when it has maximum entropy for that system. Okay. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.